everyone. Today I'm going to discuss about the impact of oxidative stress on longevity. First of all, let us discuss about what is oxidative stress. So it is a state of imbalance between pro-oxidant and antioxidant activities, right? So our body produces a lot of reactive oxidative species, ROS, or free radicals, right? Which is based on their interaction with the food we eat, our environment, the external toxins which we are getting, right? Or even excess exercise could produce or could lead to oxidative stress. How our body is also capable of producing antioxidants which can neutralize this ROS and bring the body back into, homeostasis. And again, there is a role of your microbiome in making sure that your body is producing enough antioxidants, and there's an redox balance, there's a redox homeostasis, right? So essentially, let us discuss about couple of antioxidants and the role of microbiome in synthesis of those antioxidants. So first is glutathione. Again, glutathione is there's an indigenous production of glutathione. Again, there's a role of both oral and gut microbiomes. So your oral microbiome produces nitric oxide, which activates certain signaling pathways within the cells to upregulate enzymes that produces glutathione. Right? It also nitric oxide also impacts the availability of cysteine, which is again could be used to produce glutathione. Again, your gut microbiome actually converts these non-essential amino acids, glutamate, glycine and cysteine into GSH glutathione. But this glutathione is need to be oxidized, and again there is a particular enzyme which does this act, and your gut microbiome influence the production of this enzyme, right? So your gut microbiome has certain microbes in the gut should be there and should be performing this beneficial function to actually activate this enzyme, which could oxidize this glutathione. And then again, when it is oxidized, it actually is capable of donating electrons to neutralize ROS. Right. And again, if your oral microbiome is imbalanced, if your gut microbiome is imbalanced, you're taking improper nutrition, you're taking, you do not, I think you're not taking right foods for your biology, you are using too much of mouthwash or fluoride-rich toothpaste, right? Or not flossing properly. All these could impact your nitric oxide production. All this could impact in your gut microbiome function and could disrupt your oxidation of glutathione, right? So that is one side. Other side is even if you're taking glutathione-rich foods such as tomato, right, or you are uh, consuming glutathione supplements, they need to be oxidized, and this function has to be done is done by your gut microbiome when they activate certain enzyme which is responsible for oxidation of glutathione. However, there are certain gut microbes and oral microbes which could metabolize sulfur-containing amino acids in the glutathione and actually convert into hydrogen sulfide. And again, H2S is a toxin. It could block the mitochondrial function. It could disrupt your various metabolic processes. It could disrupt your bitrate production. It could even disrupt your mucose barrier. So understanding, these biochemical functions is very, very essential rather than assuming that your body will produce glutathione, it will be beneficial. Second thing, there are certain other antioxidants such as polyphenols, flavonols. All these are something which cannot be metabolized by the human body. Your gut microbiome actually synthesizes these polyphenols and flavonols, and ellagic acid, which is again found in pomegranate, right? So if your gut microbiome cannot convert ellagic acid in pomegranate into urolithin A, right, which has a lot of antioxidant properties and which also stimulates mitochondrial efficiency and biogenesis, right? You will not be able to extract the benefit of antioxidants. Similarly, cocoa, raw cocoa, right? Raw cocoa is also have flavonols, which actually stimulates antioxidant production. Again, raw cocoa also feeds or stimulates the production of nitric oxide. And again, nitric oxide is plays a very key role in mitochondrial biogenesis because first it controls the electron transport change, it prevents the electron leakage, it stimulates the mitochondrial efficiency, it improves the mitochondrial efficiency, it stimulates the mitochondrial biogenesis by activating PGC1 alpha, which is again a gene which is activated when we need to stimulate the mitochondrial biogenesis. So nitric oxide also plays a role in prevents the telomere shortening. So your microbiome has a very important role via stimulating and activating various pathways and biochemical functions in your longevity. So do not assume that your body would be doing all these actions. They would do, provided there is a cellular and metabolic homeostasis, provided your microbiome is in place, they are performing beneficial function, they are not imbalanced, there is no dysbiosis of the microbiome, and again both oral and gut microbiome. So these have a key role to play in your longevity, in regulating your aging or reducing your aging, right? Again, these all factors impact your biological age as well, right? So it is not only about these antioxidants, your gut microbiome also produces certain other metabolites such as bitrate, acetate, propionate, right, which have a beneficial functions on your host cells as well, right? So understanding your biochemistry, your microbial biochemistry, how they interact with the human host, how they interact with your own genes is very, very important. That's it for today. Have a great day ahead. Thank you very much.